Hi students, welcome to physics classes. Now we are discussing model paper 5 class 10 physics 10th class model paper 5 physics we will discuss. Now one more questions. First question is convert 30 degree Celsius into Kelvin scale. 30 degree Celsius into Kelvins. Remember in the exams they won't give same numbers. They will change the numbers. If you understand the process, you can able to do it easily. Now when they given Celsius into Kelvins, remember we should add 273 to convert into Kelvins. From Celsius we should add 273. Now see how much they given. 30 plus 273 equal to 303 kelvins. Suppose if they asked convert into Celsius, given Kelvin asking you to convert into Celsius, so we have to do C equal to K minus 273. We should subtract. If they given Celsius converting into Kelvins, add 273. Given Kelvins converting to Celsius, subtract 273. Next question. A light ray is entering from rarer medium A to denser medium B. Light ray traveling from rarer medium to denser medium. Then complete the given diagram. Now they given diagram like this. This is the interface. This is medium A. Medium A what? Rarer medium. Medium B, denser medium. Medium A to medium B. Now complete the diagram. Now light ray traveling like this. Now when light ray traveling from rarer medium to denser medium, due to the change in speed, light ray comes towards the normal. Light ray comes towards the normal. Light ray bends towards the normal. This is the path of light ray. Any like they can give you this question. Either it will be in the top and bends towards the normal. Either bottom bends towards the normal. Remember, when light ray traveling from rarer medium to denser medium, it bends towards the normal. This is angle of incidence. This is angle of refraction. Angle of incidence is greater than angle of refraction. If they ask, then only you write. Otherwise, no need. Next question. Answer the following questions by using given table. They given a table, material and refractive index. Water, its refractive index is 1.33. Ice, its refractive index is 1.31. Now the questions, which is denser medium? Which is denser medium? Now here, which has more refractive index? Remember, they won't give you same materials and same refractive indexes. It will changes. In the exam they can ask you in any way, any material they can give you. There is no restriction to give only water, ice, like air, glass, anything he can give. So instead of remembering, understand here which has more refractive index in the given values. Which has more refractive index in the given values, that will be the denser medium. Now here 1.33, 1.31. Water refractive index is more, so water is a denser medium. Water is a denser medium. Next, in which medium light travel faster? Which medium light travel faster? Now here in the given refractive index, which has less value, less refractive index, which has lesser refractive index, in that medium speed of light will be more. Now here ice has less refractive index, so in this speed of light is more. So in ice speed of light is more. Okay. Next question, complete the given diagram. Complete the given diagram. Here they given lens. Which lens it is? Biconvex lens. Biconvex lens. Object is placed beyond 2f2. Object is placed beyond 2f2. So we should complete the ray diagram. Now here they given a ray passing parallel to the principal axis. After refraction, it should passes through the focus. After refraction, it should passes through the focus. So ray which is passing parallel to the principal axis, after refraction passes through the focus. Now second ray I am taking passing through optic center. Second ray I am taking passing through optic center. So the ray which is passing through optic center after refraction travels without any deviation. The ray which is passing through optic center travels without any deviation. So both rays are meeting here. Both rays are meeting here. So here image will be formed. Here image will be formed. Okay. Now in the question he didn't ask, but if he asked, we should be able to write answer, no? Now what is the size position of image between f1 and 2f1? What is the size of image? Size of image is less than size of object, so diminished. What is the nature of image? Real and inverted. Real and inverted. Okay. Next question, assertion and reason. Now the question is the least distance of distinct vision of a child is 7 centimeters to 10 centimeters. Least distance of distinct vision of child is 7 centimeters to 10 centimeters. Yes, it is correct. Now we'll see the reason. At a young age, the muscles around the eye are strong and flexible. Yes, this is the correct explanation of assertion. Because at the young age, the muscles are very strong and flexible. Muscles are flexible, so it can compress more. That's why they are able to see 7 centimeters to 10 centimeters onwards. Least distance means this is the minimum distance that a person can see clearly. So for a healthy person, middle age, normal age person, it is 25 centimeters. But for child, it is 7 to 10 centimeters. That is because their muscles are around the eye are strong and flexible. So both assertion and reason are true, and reason is the correct explanation of assertion. Assertion and reason are true, and reason is the correct explanation of assertion. Now two more questions. What is the reason for blue color of sky? What is the reason for blue color of the sky? Now sky color changes, that is because of scattering of light. Now when we are getting white light from the sun, white light is the combination of 7 colors. White light is the combination of 7 colors. Now when that light falls on the molecules in the atmosphere, molecules which are present in the atmosphere, now that 7 colors contains 7 different wavelengths. If that wavelength of the color is comparable to the size of the molecule, it will be absorbed. That particular color will be absorbed, and after absorbing, that molecule re-emits that color into various different directions with different intensities. What happened? When white light from the sun, white light consists of 7 colors, VIBGYOR, falls on the molecules which present in the atmosphere. If the size of the molecule is comparable to the wavelength of the light, that particular wavelength color will be absorbed by the molecule and re-emits into all the directions with different intensities. That is known as scattering of light. If atmosphere contains more number of nitrogen, oxygen molecules, atmosphere contains more number of nitrogen and oxygen molecules, N2 and O2 molecules, then these sizes of the molecules are comparable to wavelength of blue color light. So the size of these molecules, nitrogen and oxygen molecules, are comparable to wavelength of blue color light. blue color light. Then what will be happen? These molecules will act as a scattering centers for scattering of blue color light. These molecules act as a scattering centers for blue color light. So these molecules acts as a scattering centers for scattering blue color light. Then sky appears in blue color. Then sky appears in blue color. Then sky appears in blue color. Okay. Next question. Ask any two questions to understand about magnetic field lines. To understand about magnetic field lines. Now here he is asking us to ask any questions. Two questions to understand magnetic field lines. Now the question is, now first question is, are magnetic field lines closed? Are magnetic field lines closed? Second question we can ask, will they intersect each other? Will they intersect each other? Next, what is the direction of magnetic field lines? What is the direction of magnetic field lines? So here, how to remember these questions? Whenever we know the concept clearly, magnetic field lines. If you know the magnetic field lines concept clearly, you can ask the questions. First of all, whenever see magnetic field lines, what we will get? We will get into our mind shape of magnetic field lines. Shape of magnetic field lines. Okay, like this. For example, if you take the bar magnet, north pole, south pole, this one you need not to write in exam. For understanding, I am saying. So it will travel like this, north pole to the south pole, like this. Okay, now here by seeing this, first of all, what we will get, is it starting from here to here only? Inside of the magnet, is there any field? So already we know that magnetic field lines are closed. Outside the magnet, it will travel from north pole to south pole. Inside, south pole to the north pole, that we know. So magnetic field lines closed. Magnetic field lines closed. Already I made one video regarding this question, magnetic field produced by the current carrying wire. There we seen the magnetic field lines are closed. Second, next, by seeing that gaps are there, so they won't intersect. Now we can ask the question, will they intersect each other? Here they won't intersect each other. They won't intersect. What is the direction of magnetic field lines? I already told you, north pole to the south pole. North pole to the south pole, bar magnet, north pole to the south pole. Okay, like this we can ask the questions. Whenever we understand the concept clearly, then only we can able to ask a question. Okay, are magnetic field lines closed? Will they intersect each other? What is the direction of magnetic field lines? Next question, 4 more questions. Next question, 4 more questions. Now in 4 more questions, only 12th question is having internal choice. 4 more questions, only 12th question is having internal choice. 12A, 12B. One is physics, another one is chemistry. Any one you should draw. In the question itself, they will give, draw any one of the following diagram. Draw any one of the following diagram. So here the question is, draw a ray diagram for the image formed when an object is placed at 2f2. Object is placed at 2f2 in front of convex lens. Object is placed at 2f2 in front of convex lens. Ray diagrams we have to draw here. Okay, now convex lens. This is the shape of convex lens. This is the principal axis. Principal axis. This is f2. This is 2f2. This is f1. This is 2f1. You should draw with scale. Now here one object is placed. Here one object is placed. We know rules to draw ray diagrams. So if a ray passing parallel to the principal axis, after refraction, it passes through focus. It is passing through focus. If a ray passing through focus, if a ray passing through focus, after refraction, it passes parallel to the principal axis. After refraction, it passes parallel to the principal axis. So here both rays are meeting. Here image will be formed. Here image will be formed. Now when an object is placed at 2f2, where image is formed at 2f1. What is the size of image? Equal to size of object. Same size of object. What is its nature? Real and inverted. Its nature is real and inverted. Next question. How do you appreciate the working of ciliary muscles in the eye? Working of ciliary muscles in the eye. Now when we are seeing far objects, eyelids are relaxed in normal position. When we are seeing object closer to the eye, ciliary muscles will changes the focal length of eye lens by adjusting its radius of curvature. It compresses the lens. It compresses the lens. When far object, it is relaxed. When closer object, it should compress. That work is done by ciliary muscles. That work is done by ciliary muscles. Okay. Now, the process of changing focal length by changing radius is known as accommodation. Is known as accommodation. If that accommodation is not there, if ciliary muscles are not there, we can't see objects closer, and we can't see properly. Simply we can say we can't see properly. Now we'll appreciate it by, now the first point is ciliary muscles are helpful in changing focal length of the eye lens. What it will do? It will changes the focal length. Now the first point we can write here, what it will do? It will changes the focal length of eye lens. It changes the focal length of eye lens. Ciliary muscles changes the focal length of eye lens. Where these are present? Where these ciliary muscles presents? Ciliary muscles are attached to the eye lens. Ciliary muscles attached to the eye lens. Ciliary muscles attached to eye lens. So what it will do? When we see far object, ciliary muscles are relaxed. So focal length will be maximum focal length. When we are seeing far object, very far object, eye lens, ciliary muscles are relaxed. At that situation we will have maximum focal length. At that situation we will have maximum focal length. So the rays which are coming from the object, will meet at on the retina, and image will be formed on the retina. So rays which are coming from the object far, no, so that light rays parallel to each other, and they meet after refraction. After refraction from the eye lens, they will meet and the retina. Then image will be formed on retina. That we can identify. Now when we focus closer object, when I focused nearer object, when I focused closer object, muscles are strained, so focal length decreased. That focal length is decreased, adjusted by ciliary muscle. Then they will meet on retina. Image is formed on retina. So the process of adjusting this focal length, by changing the radius of curvature is known as accommodation. So this process of adjusting focal length of eye lens is called accommodation. So ciliary muscles must be appreciated for its accommodation of eye lens. So ciliary muscles must be appreciated for its accommodation of eye lens. Next question. Explain the following terms. Four definitions they will give. We should write the answers. Now the first one is refractive index. What is the definition for refractive index? Refractive index is the ratio of speed of light in vacuum to speed of light in medium. Refractive index is the ratio of speed of light in vacuum to speed of light in medium. So refractive index is denoted by letter N, speed of light in vacuum C, speed of light in medium V. N equal to C by V. refractive index has no units. Why no units? It is the ratio of two same physical quantities. Ratio of two same physical quantities. Then refractive index has no units. Second question in that optical fiber. Now optical fiber means, explain about optical fiber. Optical fiber is a very very thin fiber made with glass or plastic, made with glass or plastic, and having radius is about micrometer. Radius is micrometer, very thin fiber. A bunch of these fibers forms a light pipe. Bunch of these fibers forms light pipe. It works on the principle of total internal reflection. It works with the principle of total internal reflection, and it is used in telecommunications. It is used in telecommunication signals. Next one is critical angle. Next one is critical angle. Critical angle means when light ray travel from denser medium to rarer medium. When light ray travel from denser medium to rarer medium at a particular angle of incidence. At a particular angle of incidence. Generally, when light ray travel from denser medium to rarer medium, it bends away from the normal. As we increase the angle of incidence at particular angle of incidence, refracted ray grazes at the interface. Refracted ray graze along interface. That angle of incidence is known as, what is that? That particular angle, no? Particular angle of incidence. That angle of incidence is known as critical angle. Critical angle. At a critical angle of refraction is 90 degrees. At a critical angle of refraction is 90 degrees. It grazes along the interface, no? So we'll see, this is the denser medium, it is rarer medium. At one particular angle of incidence, light ray grazes along the interface. Grazes along the interface. This angle of incidence is known as critical angle. So in this situation, angle of refraction is 90 degrees. Next, total internal reflection. Total internal reflection. So when light ray traveling from denser medium to rarer medium, already we discussed in critical angle. When light ray traveling from denser medium to rarer medium, at a particular angle of incidence, light ray grazes along the interface. That incidence is known as critical angle. Now the same, when light ray traveling from denser medium to rarer medium, when angle of incidence is more than critical angle, when angle of incidence is more than critical angle, light ray will not enter into the rarer medium, it reflects into the denser medium. Light ray reflects into denser medium. That is total internal reflection. In total internal reflection, light ray follows laws of reflection. What are laws of reflection? Incident ray, reflected ray, normal drawn at point of incidence lie on same plane. Next one, angle of incidence equal to angle of reflection. Next question, deduce the expression for equivalent resistance of three resistors connected in series. Electric current series combination. Electric current series combination. This video already I did. It is in our channel. Once you go through it, I'll provide the link in description. Okay, this is the choice question, 15th. 8 more questions are having internal choice, no? So already we discussed the 15th A, the definitions. Now this is 15th B, internal choice. Okay, this question answer given in our channel. You can go through it. Link I will provide you in the description. Next question, another 8 mark question. Explain with the help of an activity that current carrying conductor or current carrying wire produces magnetic field. Current carrying wire produces magnetic field. This is from the lesson electromagnetism. Electromagnetism. This video already I did. It is available in our channel electromagnetism. Question Oersted experiment. Oersted experiment or current carrying conductor produces magnetic field. Current carrying wire produces magnetic field or experiment. That link I will provide you in the description once you go through it. Okay, this is the model paper number 5. Okay, thank you for watching. Please subscribe for more updates.